what happens to an electric dipole when it is placed in an external electric field. Okay, so what is the total force acting on the dipole, what is the torque acting on the dipole, what is the potential energy of the dipole when it is placed in an external electric field. So today we shall discuss about all these topics. First of all, what is an external electric field? External electric field means it is not the field of the dipole. Okay, this field is produced by some external sources. This is the applied electric field, and we are going to place the dipole in this external electric field, and we shall calculate the net force acting on the dipole, the net torque acting on the dipole, and its potential energy. Okay, so first of all, how to represent an electric dipole? We represent an electric field. We represent the electric field by drawing some field lines. Okay, so to represent a uniform electric field, to represent a uniform electric or magnetic field, the field lines should be straight and equidistant. They should be parallel and equidistant, because for a constant electric field or uniform electric field, the direction at all the points should remain same, and also the relative separation between the field lines remains same, because the flux density represents the magnitude. Flux density or the density of the field lines denotes the magnitude of the electric field at any point, and the direction and the tangent drawn at any point will represent the direction of the field lines, direction of the electric field at that point. So the parallel lines which are equidistant, parallel field lines, will represent a uniform electric field. Okay, so this is the external electric field. These are the field lines due to an external electric field. Now we are going to place the electric dipole at some orientation theta with the field direction. Let it theta. This angle is theta. Okay, so the dipole is placed. This is minus q charge, this is minus q charge, and this is plus q charge. So this dipole, and the distance is 2d. So the dipole is placed with the electric field at an angle theta with the field direction. Okay, now the force from the very beginning, from the definition of the electric field, we have E equal to F by Q. So the force acting in a charged particle of magnitude Q, charge Q, is F equal to Q into E. If a charge of magnitude Q is placed in an electric field of electric field E, charge Q is placed in an electric field E, then the force acting on the charge is Q into E, because E, the electric field, is the force on a unit positive charge. Okay, so the force on charge Q is Q into E. Is it clear? So the force, the electric field will repel a positive charge along its direction, and it will experience a force on the negative charge opposite to the field direction. So the force on minus q charge of the dipole is QE. It is minus QE opposite to the field direction, and force on plus q charge is Q into E along the field direction. Okay, along the field direction. So the net force on the dipole, force on minus q charge is minus QE, and this is plus Q. This acts along the field direction, this acts in the opposite direction of the field. Okay, so the net force F equal to plus QE plus minus QE. So the net force on the dipole in an uniform electric field is 0. The net force on the dipole in an uniform electric field is 0. But these two forces, that is plus QE and minus QE, acts in two opposite directions. So they will create a couple, and this couple will rotate the dipole along the field direction, and it will orient the dipole along the field direction. Okay. So these two forces, these two equal and opposite forces will create a couple which will rotate the dipole along the field direction. Okay. So what is the torque due to this couple is torque. What is torque? Torque, how to calculate the torque? Torque equal to R cross F. That is from the definition of class 11, that torque equal to, if two equal and opposite force acts on a body, then the product of any of the force and the line joining between the two forces, that is a perpendicular distance between the line joining of line of action of two forces, is called the torque. So this is the line of action of the first force, that is plus QE, and this is the line of action of the second force. So what is the perpendicular distance between the two forces? This is, if this is theta, then this is 2d sine theta. If this is theta, then this is 2d sine theta, isn't it? So torque equal to any of the force into the perpendicular distance between the two forces. Is it clear? Any of the force, magnitude of any of the force, that is QE, into the perpendicular distance between the two forces. So this is equal to QE into perpendicular distance. If this is 2d and this is theta, then this is 2d sine theta. Okay. Now dipole moment P equal to charge into the separation distance. Okay, so this is equal to P sine theta. Vectorically, it is given by tau equal to P cross E. Okay. So this is the torque acting on the dipole. Now, what is the total energy